All right, this is the Indirect Determination of the Masses of Pieces of Magnesium lab. Nice short title there. But it is one of my favorite labs. We're going to take this little strip of magnesium, very thin, and we're going to dissolve it in acid, and as it dissolves, as it reacts with the acid, it's going to produce hydrogen gas. And we're going to collect that in this tube. It's called a eudiometer, or a gas collecting tube. And it really just looks like a very long test tube. It's closed off at the top here, and there's markings on the side. And I'll show the markings, but here it says 2, 4, 6, 8. What's great about this is as we're going to collect the hydrogen, it's going to collect it over water. The hydrogen is going to come up here. When we're done, if the hydrogen goes down to 10 mils, we've collected 10 mils. It's very easy to read this off. Okay, so what we're going to do is we're going to do it this way. We're going to fill it with 10 mils of acid, hydrochloric acid, and I think it's 6 molar. Yeah, 6 molar. It says 5 mils, but this is a larger eudiometer than it's a 100 mil one. So we're going to double the amount of the acid just to make it go faster. It'll still work at 5, but it'll take a lot longer. All right, and then we're going to put in the acid. We're going to fill it up to here with water, distilled water, and then we're going to put our sample in. And our sample, it's going to be magnesium. It's going to be wrapped in copper. It doesn't say that to do that in the lab, but if we don't, when we flip this thing, we're going to flip it, and we're going to put it into the water here. As the hydrogen, the sample is going to be at the bottom here, and the hydrogen is going to bubble up. But if we put the magnesium in there, often just on its own, often it just gets so covered with bubbles, it works its way up and it floats to the top, and then it sticks to the side, and the reaction is over faster than it should be. So we wrap it up in copper. Copper doesn't react with the hydrochloric acid, so it'll sit down here as a bundle. We'll put it into the water, and then we'll just let the reaction occur. The big thing, and the one that causes the students the most trouble, is that we have to flip this. Once we fill with the acid, the water, put our sample here, we get it all set, and then we flip it over and into the beaker of water. This is just tap water because it's not going to go into the reaction itself. And you want to, when you do this, when you flip it over, you want to use your index finger, not your thumb. Students will often do that before it can catch them. So you do this, and then you can't you can't do anything there. You have to do this, and it's going to splash. That's fine. And you take it down to the bottom, and stand it like that, and then the reaction goes. So that's what we'll do. Splashing the water, it's just tap water, no problem. You say, well, what about the acid? Well, the acid does make its way down, but it takes a long time. It takes several seconds for it to get down to the bottom. So when we start, there's nothing in it right now. When we put the acid here, we add in the water. It doesn't mix very well. And so when you flip it over like this, the acid starts coming down, but it takes a long time, so you've got plenty of time to do this maneuver, though it is a little stressful the first time you do it. Okay, I'm going to dry off, and we'll get started here with the preparation of the sample. So we're using unknown 20, and here's the sample. Magnesium is wrapped up well in the copper. So you don't want to cover it so much that the magnesium or the acid can't reach the magnesium, but you want to get it good so that if the magnesium will eventually dissolve enough to break into pieces. So when those pieces do escape, you want them to be, when they float up to the top, to dissolve away before they get stuck to the sides. So this should hold the magnesium pretty well. Then you want to try putting it into the eudiometer and see if it'll fall out. And that'll make it a lot easier. If it does fall out, you would just try to grab it on the bottom of the beaker, which is a little tricky, but it's best if you can get it so the sample will hold. And then those little copper legs will keep the eudiometer from sitting flush on the bottom of the beaker, so that there'll be a little gap for the water to escape as the hydrogen is produced. So it's hard to show everything here because the eudiometer is so long, so we'll just show from the bottom here. So I'm putting in the last of the 10 mils of the HCl, just so you don't have to watch the whole thing. Now I'm going to put this into the eudiometer. You should see it filling up. that's the 10 mils of the hydrochloric acid that went in. And now, put it up a little bit. I'm going to take the distilled water and fill it up, not quite to the top, and I'll show you why. Once we get there, it's mixing with the acid, but as it goes up further and further, the acid lags behind. It takes a while for it to mix. We'll get it here. Okay, and I'll show you what we're going to be doing at the top with the sample. All right, so here's the top of the eudiometer, and we're just going to fill this up with distilled water until it's beading over, because it's just water, so it's okay if it spills. Then I'm going to put the sample in, like so. Because you don't want to have any air bubbles in there, because the air is going to go back up, and we're going to assume that's hydrogen. We're going to have to, so we don't want this. Don't want any in there, so I'm just going to bead this up, and then I'm going to put my finger right in there into the water and splash it around. That's okay, and we're going to splash it into the beaker. It's going to be a mess, so that's awesome. Okay, so I'm going to do a faraway shot of me flipping this over, hopefully doing it right. All right, I got to do this really quick here, so sure. Yeah, so I'm going to have this sit here. I don't have it on here. I'm going to move everything here, but right now this is just easiest. So I'm going to take this down, my finger over the top, flip, and it goes into the water. And the trick is that you can't let go until your finger's under the water. If you let go up here, it's just going to splash out. Once it's under the water, you're set. Then I'm going to put it down. If the sample falls out, I'm just going to move the eudiometer around till I get it inside, and then we're all set to go. We just have to let the reaction go. Okay. All right. This is take 83. So this is the first time, so hopefully everything goes well. So we're just gonna take this, flip, in we go into the bottom, and water everywhere, like I said, but it's okay. And it's already started to bubble. That's because it's been taking me so long to get everything set that the hydrogen or the acid has made its way down. Yeah, it's going. Probably can't see it yet, but I'll show a close-up of it. But now it's all set, probably about 10 minutes, and then we can look at the results. But I'll show you up close what the reaction is doing. All right, this is about 2 minutes in. You can see that the hydrogen gas is going up. There's big bubbles, and then there's the little bubbles there. The acid is making its way down. It's increasing the concentration of the acid at the bottom here, and that's making the reaction go faster and faster. Okay, and there you can see the magnesium. That's the silver part. It's just covered with bubbles. The copper looks like it's reacting too, but it's just getting covered with the bubbles of hydrogen from the magnesium. The copper is unaffected. And I'm going to go up here. Where is it? There we go. You can see the bubbles, the hydrogen is being collected over water. I'm having trouble with the focus, but I think you get the general idea. Yeah, there you go. And you can see the volume of the hydrogen gas is getting larger, and it's just going to keep dropping. The water level, the solution level, is going to keep dropping for about 10 minutes. Then we're going to come back and we're going to get the volume of the hydrogen gas, and then we're going to find out the height of the water column above the beaker, and we'll need the temperature, and we'll need the barometric pressure. I'll give all of that stuff. But we'll just let the reaction keep going here, and about 10-15 minutes is all it takes. Okay, so we can see that the reaction is done. There's some bubbles, but no bubbling. And we go up, and I have the meter stick at the surface of the water. I'll show you why in a second. And then, so we're going to measure the water column height, which is here. And then we back up and you're going to see the volume of the hydrogen as well. So what's happening here is that down here, the atmosphere is pushing down on here. And so it should be on the water, so it should be pushing the water in. But if nothing's moving, then the pressure outside must be balanced with the pressure inside. So the pressure outside is the atmospheric pressure. The pressure inside, that's pushing back down, would be the pressure of the hydrogen gas in here, the water vapor that's in there, that's always there when we collect a gas over water, and then the pressure due to the water column itself. So that's why we need that height. And we also need to know the temperature, which is 21 degrees Celsius, and I'll write that down later. All right, so that's just what, let me back off here. That's what it looks like, and then I'm going to do a close-up of the water column so you can see, make the measurements. So here's the water column, and above it is the hydrogen gas. As I said, the numbers on the eudiometer, those numbers on the left in white, that's the volume of the gas collected. So you can see 36 there, and we're past that. And the numbers are counting up as we move down the column. So we're past 36, and notice that the next number is 38. So there's the longer mark in the middle there, that's 37. So each of the smaller marks is 0.2 mils rather than 0.1 as usual. So if you look at it there, we see 37, 0.2, 0.4, 0.6. So 37.6, we'll just say 60, though we can estimate, but it looks like it's right on the line. And then on the right is the meter stick, and that's giving us the height of the water column. So the numbers are going up as we move up. You can see it says 40 centimeters, and it's 41, 42, 42.5, 6, 7, looks like 42.7, we'll say 70. We could estimate in between, but I think that's good enough, and it looks like it's pretty much on that line. Here are the results for the first run, unknown number 20. There's the volume of the hydrogen. The temperature, the barometric pressure is 741 torr, or millimeters of mercury. And then the difference in the water levels, or the height of the column, is 42.7 centimeters. And here's the information for the second run, just save some time. So you can see the volume was, for this one, unknown 27, the volume was 43.95 mils. Temperature was the same, barometric pressure was the same, and the difference in the water levels was 40.10 centimeters.